Hey everyone, in this video, I'm going to go over what a linked list is, some of the differences between linked lists and arrays, and finally, the operations that a linked list has. So first, let's talk about what a linked list is. So a linked list is a linear data structure, but unlike an array, the elements are not stored at contiguous memory locations. What that means is that with an array, each element of the array are stored in memory right next to each other. Whereas with a linked list, each node or each element are stored at different places, and they don't have to be next to each other. And so linked lists use pointers to reference the next element or node. And so a couple of terminologies. The first thing is a node. So think of a node as a data source in the linked list, and it has two parts. The first part is the data, and the second part is a pointer that points to the next node. And sometimes, depending on the type of linked list, as we'll see in a bit, you can also point to like the previous node. The head is the first node in a linked list, and the tail is the last node in a linked list. So there are many types of linked lists, and these three are the most common. So first, a singular linked list. This is by far the most common linked list that you'll encounter. So each node has one pointer that points to the next node. And so, for example, right, you can see like here we have the head, and the head's pointing to the second node, and the second node's pointing to the tail, and the tail's pointing to none or null because there's no node after the tail. The next type is a doubly linked list. So here, each node has two pointers, one that points to the previous node and one that points to the next node. And so if you look at the head node, right, its previous pointer points to null because there's nothing before it, and its next pointer points to the second node. If you look at the second node, its previous pointer points to the head node, and its next pointer points to the tail node. And if you look at the tail node, its previous pointer points to the second node, and its next pointer points to nothing because there's nothing after the tail. And finally, we have the circular linked list. So a circular linked list is very similar to the singular linked list, but with one difference. And that difference is that the tails points to the head. So if you look at this diagram, right, again, like each node has one pointer that points to the next node. But unlike a singular linked list where the tail points to none, in a circular linked list, the tail points to the head. And there's like stuff like doubly circular linked list where each node has like a next pointer and also a previous pointer. And in that case, the head's previous pointer will point to the tail, but that's pretty rare. So I didn't cover it in this video. So now I'm going to talk about some operations that linked list has, as well as its time complexity. So the first operation is accessing an element. And the time complexity of this is O of n because in order to access a specific element, you have to loop through the linked list. And so that's why the time complexity is O of n. Insertion or removing from the beginning is O of 1 because you just either add a new node and like make the edits with the pointer stuff. We remove the first node and you just set head to the second node. However, inserting or removing from either the middle or the end is O of n because you have to traverse through the linked list and then traverse through the linked list and then like change the stuff with the pointers. So that's why it's O of n. Thank you all for watching. I hope you learned something.